On number one, you're going to use the formula that the area of a parallelogram is its base multiplied by its height. They give you an area of 48. The base is 4, and you're trying to find the height. So this is just a one-step division problem. This will be that h is 48 over 4, which is 12. On number 2, and I'll be erasing my work between problems, so you should be writing as you go, or pause me now. On number 2, we want to find the length of a diagonal of a rectangle. Well, I really think what you need to do is draw a picture. Here's a rectangle. Right angles in the corners. This is what you're after. You're after the diagonal. Now, in order to get the diagonal, you need to know the length and the width. Then you can use the Pythagorean theorem. Well, we have that the area is 21. Well, area is length times width. Sometimes we call that base times height, but it's the same thing for a rectangle. Not for a parallelogram, but for a rectangle it is. So plug in the area, 21. Plug in leave the variable L for length and put 3 for the width. Okay, now divide. L is equal to 7. Now what you have is you have a right triangle that contains, well, let me just draw it up here on the original figure. The length is 7, the width is 3, and you're after D. So D is the hypotenuse, so you're going to write 7 squared plus 3 squared is equal to D squared. That's going to give you that this side over here works up to 58. That's D squared, and since we know D is positive, D is the positive square root of 58. To the nearest tenth, that would be that D is equal to 7.6. So either one of those two would be fine. What you need to know about number 3 is that the height of a rectangle, a height of a parallelogram, is the distance between the parallel sides. So this 4 measures the distance between these two parallel sides, and they would both be the same. They'd be 8. So the 4 is the height. The 8, either one of them, is the base. Area of a parallelogram is base times height. So it's 8 times 4 is 32. On problem number 5, well, two points you should get right away is that the area would be measured in square units, centimeters squared, and perimeter would be regular centimeters. You should fill those in right away so you don't forget. What you want to do is divide this figure into two things that you can find the area of. Now, if I call this area 1 and area 2, then the total area would be area 1 plus area 2. Area 1 is easy. It is 10 by 14, and it's a rectangle. So, area 1 is 10 times 14. Plus, we need area 2. Well, we know that it's 8 across. The way we find this missing piece is that up and down in total, looking over at the left side, has to be 10. Well, it would take 4 right here to make that work. Okay, so area 2 is going to be 8 times 4. That works out to be 140 plus 32 is 172, and your units are square centimeters. On the perimeter part, perimeter just means add up the distance around. Now, across the top would be the same as across the bottom, and across the bottom is 14 plus 8 is 22. So if you simply add together all of the parts, I'm going to erase the area part and calculate the perimeter now. Let's start with the 10. 10 plus, going across the bottom, 14 plus 8, which we know is that 22. I guess I could have done that. Plus, now you got to get this part right here. You got to get that 6 and then the 4. Plus 6 plus 4. And then plus 22 across the top. Well, I can see that 24, this part is 32, that's 38. 38 and 26 is 64. Okay, on problem number 6, this is one of these work it backwards problems. You take the area formula for a triangle, which is 1/2 its base times its height. You plug in that the area is 35. That equals 1/2 of its base, which is 7, times its height, which is what you're after. If you multiply both sides by 2, you will get 70 equals 7h. The 2 times the 1/2 cancel each other out, and dividing by 7, 10 is going to be your answer. A square, can have its own formula if you want, but if the side of the square is x, then x times x would be length times width. The area is x squared. Well, if the area is 49, then 49 is x squared. X will be the square root of 49. Your answer is 7. On problem number 8, you can't see the point A, it's just out of the picture here, but you can see it on your quiz. You're trying to find the area of the triangle given what I've marked on it there. Well, this 10 is the length of segment BD, and that length is a height of the triangle, an altitude. The side that it forms a right angle with, which has length 12, is the side that you must use for the base. So using the formula, area is 1/2 base times height. You have area is 1/2 of 12 times 10, and that's 60. You've got a trapezoid in the next one, and you have that AD is 10. You have that CE is 6, BC is 3, and CD is 7. Well, again, this is about recognizing what is a height. The height of the trapezoid is this 6. It's measuring the distance between the two bases, the parallel sides. The formula is that area is 1/2 the height, which would be the 6, times the 10 plus 3, the two bases. And that works out to be 39 for your answer. On our next guy, you have a rhombus. And you've been given the entire segment in red, AD is 10, and the entire segment in blue, BC is 16. Well, those are the two diagonals of the rhombus, and you have a formula for the area of a rhombus. The area is 1/2 D1 D2. So you get 1/2 of 10 times 16, and that's 80 for the area of the rhombus. Number 10 is another rhombus problem. And again, the correct name of this rhombus, the way it's labeled there, should have been called AB DC, because you go around in order when you name it. Okay, so what we have here on this rhombus is that AD is 10. That's a whole diagonal. I'm going to mark it as 5 and 5, remembering that diagonals bisect each other. And I'm going to put in that you have right angles in the middle, because that's a property of every rhombus. We also know in this guy that CE is 6, and E is the point in the center there. Let's see. I can't quite see my picture here. Okay, I can see that I was reading the information from the wrong problem here. Okay, I can see that we had actually done that problem already. So we were ready for number 11. On number 11, we're finding the area of the rhombus. The perimeter is 52. Now remember, each side of a rhombus is the same length. So each side call that S for a side length, would be 52 divided by 4 would be 13. So every one of these sides is 13. If BC is 24, then it gets divided into two pieces that are 12 and 12. Remember that rhombi have perpendicular diagonals. That means if I put an X there, I've got an X here, and I can use the Pythagorean theorem on this triangle. I'll outline it in blue. This triangle right here would be x squared plus 12 squared equals 13 squared. So if we solve that, x squared plus 12 squared equals 13 squared, in a couple of steps you'll be taking the square root of 25, which is 5. Well, that means that AD, which is the other diagonal, would be 5 times 2 is 10. So now you have the two diagonals. One of them is 10, the other one you started off with at 24. So the area is 1/2 of 10 times 24, which is 120. To figure the number of square centimeters in a square meter, think of a square that is 100 centimeters on each side. Then its area is 100 times 100 is 10,000, and that's square centimeters. To find the area of an isosceles triangle, I'm going to need to work up above it, so I'm going to erase the information on that square problem. What you can do, and it's in the hint there, we know how long the base is, it's 16, and we know the legs are 10. Well, it says that the height will bisect the base. That means it divides it into pieces that are 8 and 8. And again, here comes the Pythagorean theorem. H squared plus 8 squared equals 10 squared. And when you solve that, you'll have the square root of 36, which is 6. Now to get your answer, the area is 1/2 base times height. So the area is 1/2 of 16 times 6, and that's 48. Okay, number 14, we're going to buy some carpet, and the area of our room is 10, the room is 10 by 20, so its area, now this would be in square feet, would be 10 times 20, which is 200 square feet. Well, that means that the area in square yards would be 200 square feet times 1 square yard is equal to 9 square feet, because it's a 3 by 3 square. 3 times 3 being 9. Well, the feet cancel now, and you get that the area is 200 over 9. If you multiply that by the cost, by $23 per square yard, then the cost is this 200 over 9 times 23. And that works out to be $511.11. Okay, this is a solve it backwards problem with trapezoids here. The area of the trapezoid is 150. The formula is that the area is 1/2 the height times the bases added. So you have area 150 equals 1/2 of the height 30 times one base 8 plus the other base that you don't know. I could call it B2, but it's the only base now I don't know, so I left it as B. Well, this would be 150 equals 1/2 of 30 is 15 times 8 plus B. I'd notice that 15 goes evenly into 150 10 times and divide both sides there. So 10 is equal to 8 plus B, subtract, and the base is 2. In this problem, number 16, we have angle B being 60 degrees, BC is 10, AB is 12. Well, what you need for any triangle is to find the height, and that's that segment right down the middle. I'll put an H on it. We're going to use our 30, 60, 90 rules. Some of you thought that you could just split the base equally. You could only do that if you knew this side was 10, and we don't know that. And in fact, it's not. So, if I use the rule that hypotenuse equals short times 2, that rule will be on your formula sheet, by the way. That would be that 10 is equal to short. Now, short would be down here. I'm going to put a variable there, x times 2. So x equals 5. This little guy on the bottom, both pieces on the bottom, are 5s. Now if you use the rule long equals short root 3, you'll have your height. So that would be h, that's your long leg, equals the 5 square root 3. So now you're ready to get your area. The area is 1/2 of the base, which was given at 12, it is 10, it's the length of BC there, times the height, which we just figured out at 5 root 3. And that looks like it's 25 square root 3. And to the nearest tenth, $43.3. Okay, number 17 is sort of similar to the last one. This 12 will be a base, and this distance here will be the height. And we can get the height using 45, 45, 90 rules. This is a 45, 45, 90 triangle. So what we have is that for 45, 45, 90s, hypotenuse is leg root 2. That means that 10 is equal to h square root 2, or dividing by root 2, h is 10 over the square root of 2. Now you could simplify it, but we're going to convert it to the nearest tenth anyway, so we're not going to. So my area is the base of 12 times 10 over square root 2. That's 120 over the square root of 2. I'll pop that into a calculator and get an answer to the nearest tenth. 120 divided by square root 2 is 84.6. Okay, the formula for the area of a regular polygon, a regular n-gon, is that the area is 1/2 the perimeter of the base times the apothem. Well, you've got enough information here to get the perimeter of the base. You know it has 20 sides, and they're each of length 3, so that's 60. And you're given the apothem. So this is 1/2 of 60 times the apothem, which is 3. 20 gon, 20 times 3. Okay, and this is half of 60 is 30 times 3 is 90. I just want to check this real quickly. The 20 gon, 20 sides, each side is 3. Okay. Oh, the apothem was 6. That's where I messed up. And we'll try that final answer one more time. So this is 30 times 6 is 180. Sorry about that. Okay, find the area of a regular polygon. It's a hexagon whose sides are 20. You need to start off in these problems with the central angle. The measure of the central angle is 360 over the number of sides, which was 6 because it was a hexagon. That's a 60-degree central angle. Draw your central angle picture. That 60, when we put in the apothem, which we need, will be split into 30 and 30 up top. Okay, that leaves us, because these two are equal, we can figure out those remaining angles are 60s. We're dealing with a 30, 60, 90. So, we can find out these lengths. Well, actually, we know these lengths, because we know that the sides were 20. So this is 20 each of these little guys would have to be a 10. If I use my 30, 60, 90 rules, that long equals short root 3, that will give me that A is 10 root 3. So we've almost got the perimeter, not quite. The perimeter is going to be, the sides are 20 and there are 6 of them. 6 times 20 is 120. So now we can do the area. The area is 1/2 of the perimeter, 120, multiplied by the apothem, 10 square root 3. So this area is 600 square root 3. It is an exact answer. And 600 square root 3 is 1039.2. So my final answer here in the box, 1039.2. Okay, in this problem you're given the radius of the circle is 5, arc AB is 72. To get the arc length, you take the degrees in the arc, you divide by 360, and you multiply by the circumference of the circle, because this is that fraction of the circumference. And that would be, the circumference is 2 pi times the radius of 5. This works out to be exactly 2 pi. It said leave pi. If you did give me the decimal, then 2 pi is 6.3. The area of the circle is pi times its radius 5 squared. That's 25 pi. And again, if you give that to me as a decimal, 25 pi is 78.5. And to get the area of the sector, remember the sector is this little piece here. Again, it's like A, you take 72 over 360, but this time you multiply by the area of the circle, which we found out in the problem before was 25 pi. This works out to be 5 pi is an exact answer. The approximate answer for 5 pi is 15.7. So approximately 15.7. Okay, on Friday you're going to take a quiz that's just like this one, numbers changed, and you will not be able to use your notes or your book like you did on this one, but you will get a formula sheet. I'll give it to you today so you can see what it's like. You will get a formula sheet that has every formula I've used here. You just have to know how to use them.